Hello everyone. Today we are looking at another Leetcode problem. This is 3440 reschedule meetings for maximum free time number 2. So this is second in its series. We solved the first one yesterday and I will have the link to that problem in the description. Feel free to check that out. So let me recap the problem setting. So in this problem we are given a time window, okay, which is going to start from 0 and goes up till event time, which is an integer value that they've given to us. Now, apart from that, we are given two integer arrays. We are given the start time and the end time. So let's say if our meeting starts at 3 and ends at 5, so I can have that represented like this. And let's say another one starts at 7 and ends at 11, then I can represent it like this. Now, in this problem, what they say is that we can reschedule at most one meeting, and it is okay for me to reschedule and place this meeting out of order. Okay, now this condition is what is new to this problem and is different from yesterday's problem. Okay, and given this, we have to find the maximum free time possible. So we have to find the largest chunk of free time that is possible. Okay, let's quickly recap what we saw yesterday. Okay, so what we saw yesterday was that if I had a meeting which was, let's say, somewhere here, and I had another one somewhere here, what we did was in this first one, we shifted this to the left, and in the second one, I shifted this to the right. Okay, and in the second one, what we did was we picked this one and this, which was this one, and we moved it together. So what we realized last time was if I'm shifting this one, I have to place it in this window range only, which is this. Okay, starting from here till here. So it has to be in order. Order was important. So it had to move somewhere in this. And the only way for me to get the largest window size was to push this meeting to either the left or the right and create the space, because this particular space that I have actually starting from here. So let's say this particular space that I had was fragmented. So this particular time chunk, we called it T1 in the last video. This particular time chunk, we called it T2. So I was only able to get T1 and T2. But if I move this particular meeting to one side, I would be able to get T1 plus T2. And so that's what happened. After moving it to this place, this much space was available to me, which was nothing but T1 plus T2, and that's how I maximized it. Okay, and then again, our learning from this particular example that we looked at was if I move to consecutive ones, if I move the consecutive meetings, then I'm able to extract an even larger window as compared to moving to isolated meetings, because here we are able to get some free time, but what we want to do is put those free times together. So we're not just looking at the total free time, but we are looking at the largest free time window. So we need to look at consecutive meetings. Now, with this understanding, what we realized that we would have to use consecutive values and we would have to push it to some side. So, which means the maximum that we could get always was T1 plus T2. If I moved one meeting, it was always T1 plus T2. But in this problem setting, in today's problem setting, what they're saying is I can completely, let's say, if my setting was like this, okay, and this was my meeting and this is my window, and so this is my T1 and this is my T2. Last time, what we said was I can move this to one side and then what I would have is this window, which becomes T1 plus T2. This time, what the problem is saying is that if I have a meeting in between, this is T1, this is T2, and let's say the size of this meeting or the duration is 1. So what this one is saying is I can take it out, okay, from its place and reschedule it to out of order here or here, anything is fine. Which means now the window of free time that I'm able to generate is much bigger because I'm able to add the meeting time also, which was getting subtracted the last time. But what they say is this change can be done at most one time. That means there is a possibility that you do it 0 time, which means you don't take the values, that means you don't reschedule the meeting, or you reschedule it and you reschedule it out of order. Now, it is not necessary for us to reschedule the meeting out of order. I can do this setting also. This is also okay for us. So that is why we will be comparing two cases. Case 1, where I free up this space completely. Case 2 is when I am still in that window, but I'm having the window in order. So that means it's either moved to the left side or the right side of the free window that I'm creating, but it is not moved out. Okay, so now this is what we have to see. Okay, but there is, because I can move a meeting out of its window and place it somewhere else, I need to first figure out, is there another free space where I can push this? Okay, so what we're saying is, if a meeting was here and this was the window means this is the end of the previous one. So this is the end, and this is the start of another meeting, start. And so this start of next one minus, so next start minus previous end is what defines my window. Okay. Now in that, what I'm saying is that if this one has to be moved out, okay, I need at least some free space somewhere else outside this particular window that I'm considering. Okay, outside this particular window, I need this to go outside and sit, not here, here, where there is some space greater than or equal to the meeting size. So identifying this thing is the key. But I cannot look for these free slots as I am reviewing these meetings, because the constraint on the meeting size is that it is of at least size 2, and then it goes up to 10 power 5. So for every meeting, if I'm looking at every other meeting and identifying the slots, I would end up with a time complexity of n squared, which would not work for us. So it's quite obvious that what is best for us is to do some sort of pre-processing. To do the pre-processing, okay, and have the states or status ready for us. Okay, which means if this is index, if this particular one is index, then what this index will tell us is there free space somewhere to move this meeting out? Okay, that's the question that this status array should tell us, that is there some place that I can move this out? If so, I would like to move it out and check how much space am I able to generate. So to do this, we need to create this array. Let me call it reschedule status. Okay, and what I will do for this is go from left to right, okay, and maintain maximum free window so far, and for every event check if maximum on left is greater than or equal to my current meeting time. Current meeting time. If this is yes, that means I can place current meeting um, on left side somewhere. Okay, I don't know the exact index where this max exists. I don't need to know as well, but I know that there is some spot on my left hand side, a free spot where my current meeting can go and reside. Now that much is okay because we just have to move one meeting. So just having the max variable is okay for me. Now, what if there is nothing on the left hand side, but there is something on the right hand side? So we will do the same operation from right to left, and we'll check, is there a free slot on my right hand side that I can use to move my current meeting? That's the question that I'm going to be asking. Okay, so that is what is going to define the status array, and status will be true if it can either go to the left or the right, and false by default. Okay, so let's write the logic for this, and then we will put it together with one comparison code. Okay, so first let's write a pseudo code starting with max free time, and here I get event time, which is an integer. Then I get start time, which is list of int. Okay, I also get end time, which is list of int. And then what I have to return is the size of the maximum free window possible. So that would be an integer. Alright, so n is equal to len of start time, and let's have a reschedule status array which is equal to false by default for n meetings that I have. So for dash in range of n. Okay, now we will have our max so far. So let's add a comment because we're going to be doing this two ways. So this is left to right that we are doing, and we take our max so far is equal to 0, and previous n is equal to 0. Now I need previous n here because there are two states that are possible. State 1, that my meeting starts at 0 itself. Okay, that's alright. And state 2, where my meeting starts at some value greater than 0, let's say 3. Okay, so when I'm at this state, then I have to subtract 0 from the previous n, which is not there. So it's going to be 0. But in other cases, what's going to happen is I'm going to subtract the start from this n. So my n can be this value in cases where it is index is greater than or equal to 1, and for index equal to 0 I can have this state. So I'm just going to simplify the code and say this is also a previous n, this is also a previous n, and this is also a previous n. So this is also previous n, this is also previous n, and this is also previous n. I'm going to maintain that in this variable, and that's going to simplify our life. Okay, so now this is done. let's start our for loop. For index in range of n. What is my meeting duration? So my meeting duration is easy, which is nothing but n time of index minus start time of index. Okay, that happened. Now what I'm going to say is my meeting time greater than or equal to? So is the meeting that I am reviewing here, is this greater than or equal to a empty slot that I found? Can this fit here? Oh, sorry, is it lesser than or equal to? Is it lesser than or equal to a empty slot that is available there? So if max so far is greater than or equal to my meeting duration, that means my meeting duration can happily sit in that spot. So now I can update my reschedule status for this index equal to true, which means I have a spot on my left hand side. I can place this on my left hand side. Now let us also update max so far. Let us check if it is greater. So max so far, comma, what is the current start time minus the previous n. Okay, so we are saying, okay, this is another window, right? Because there is another one ending here. I'm saying this particular space between these two things, I am looking at this index, but there is another spot here, right, which will become the left to for others on the right hand side. So I need to add this also. I need to check with this. Is this the largest that I have seen on the left? That's what I'm doing here. And finally, my previous n should also get updated. So I get n time of index. Okay, so this is done for one direction. Now let's do the other way, which is right to left. Everything is similar. Max so far becomes equal to 0. Now instead of, so when we were going from left to right, we had this endpoint to worry about, because at point your previous end was here. In some cases your previous end was here. So we were using this. Now when we are going from right to left, we have similar problem. Okay, now this can be our next value that we want to subtract from, or sometimes it can be part of a meeting. So we are going to do the same thing. Next start by default is going to be this value, which is our event time. So restore is similar. We say for index in range, but going in a reverse order, n minus 1 minus 1 minus 1. And here we say our meeting duration is equal to n time of index minus start time of index. Now if max so far is greater than or equal to my meeting duration, that means there is something on my right hand side where this meeting can fit. That's good enough for us to know. We don't need to know the exact index. So we say reschedule status of index is equal to true. So by using the same array, what we are saying is that either we have a space on left hand side, or we have the space on right hand side, or maybe both. Doesn't matter. If either one of them satisfies, the index will be holding the value true. Let's also check our max so far if this has gotten updated. Max so far, comma, next start minus n time of index. Okay, so this is what we have to do. Another thing, we should not forget to update our next start, which started off with event time but will be now start time of index. So when we move backward, this will be our next start. So now we have finished updating our reschedule status array. So now we have an array which is a boolean array. Okay, now let's leverage that and check what is the maximum window possible. So max free time, let's say, is the variable that I'm using to find the maximum possible window. I will go from index in range, it will go from 0 to n minus 1, and I will say my previous n is equal to end time of index minus 1 if index minus 1 is greater than or equal to 0, obviously, right? So if it is in, which means if this is my 0th index, and what we're saying is that from here minus 1 does not exist, then I can use 0. Okay, so if not, my previous end time will be same way. My next start is equal to start time of index plus 1. Now this is possible if index plus 1 is lesser than n. Okay, which is if this is n minus 1 and I'm looking for plus 1 which is outside this bound, then I can return the event time here. Okay, so we got our previous end and next start available. Now let's check if reschedule status of index is true, then we say my max window is equal to next start minus previous end. That's all. Else, what we're doing here, is one case where if this was the window, okay, this is the last meeting, this is the next meeting, and this is the index that we are looking at. So here what we are seeing is that we are subtracting from next start the previous end, and so we are taking all of this, which means this is actually moving out. Why? Because this status is true. That means there is some gap somewhere where I can do that. Now, in case I cannot do that, in case I cannot push this out, the maximum window size that I can create is by pushing it to a left like this. So then this would become something like this. So this is the maximum that I will be able to get. So let's say in this case my max window will be equal to next start minus previous end minus this meeting time, which is end time of index minus start time of index. Once you have this, then you just say max free time is equal to max of max free time comma this one, which is max window. That is it. And so finally you can return this variable, which is max free time. Now if you look at the time complexity of this, we are traversing the events or the meetings from left to right, so it's 2n, and the third time we are traversing to see what is the maximum window that we can get out of it. So the time complexity is approximately order of n, but we are also using extra space to maintain the states, which is also of the size of n. So these are the time complexities.